Hello and welcome to section 9.5, which is talking about our polar form and finding slope and arc length and area. Now when we're talking about slope in a polar form, remember that your f function is a differentiable function in terms of theta. So basically r is equal to f of theta, okay, like y is equal to f of x. Same concept. Your point, remember, is r and then theta. Theta must be in radians, remember. Now this is very much like our parametric form of our derivative. So dy over dx is equal to dy over d theta divided by dx over d theta. Now there is an alternate form of our slope of our derivative in polar form, and you may be thinking, how on earth did they come up with that? Well, remember in 9.4 we went over y is equal to r sine of theta, x is equal to r cosine of theta. Okay, well remember that r is actually your f of theta. So when they ask us to find the derivative, we're using a product rule. So we would take the derivative of the first times the second as is, plus the derivative of the second times the first as is. Okay, so that is our numerator, dy over d theta. Same thing with our x, the bottom there. If you do your product rule, you end up with, remember, r is f of theta, so we'd have our derivative cosine plus the derivative of cosine is negative sine. That doesn't look like a theta up there. Okay, so if you want to use this formula and you're like, I do not remember how to do it, now you know how you can derive it. You're just starting out with what does y equal, what does x equal. Substitute your r out of there with f of theta, and then just do a product rule. Okay, so they may ask us to find horizontal and vertical tangent lines for r equals sine of theta. Well, if they want to know anything about tangent lines, they want us to find dy over dx. If you're looking at horizontal, that's where your slope of the tangent line, and I'm going to use m tan because I might be able to write that a little bit skinnier. That's where your slope's equal to 0. Here is where your slope of your tangent line or your derivative is undefined. Okay, so we just need to find dy over dx. Okay, now you can use your either form of your derivative, whichever way you want to do. And what sometimes people like to do is go ahead and do that x is equal to r cosine of theta and make a substitution. Well, r is equal to sine of theta, so I'm going to substitute that in. So see right here, r is equal to sine of theta, so I can rewrite it. Okay, so now if I find dx over d theta, okay, it's going to be a product rule. I'm going to have the derivative of sine, which is cosine, times cosine as is, plus the derivative of cosine, which is sine, times sine as is. So this becomes cosine squared theta minus sine squared theta. Okay, then I can do that same concept with y. Y is equal to r sine of theta. Okay, so that r, I'm going to substitute that out with sine. Okay, so that gives me sine sine. Ooh, well this is nice because that's just sine squared. So now instead of using a product rule, I can use a chain rule. So 2 sine of theta times the derivative of sine, which is cosine of theta. Okay, so now I can find my dy over dx. by taking dy over d theta on top and divide it by dx d theta. Okay, so for the horizontal, I am going to set the numerator equal to 0, because your fraction is going to equal 0 when the numerator equals 0. Okay, ooh, how did that change into 2? Boy, you got to watch me every minute of the day. That was sine. There you go. Okay, so if I divide by 2, I'm looking for where sine is equal to 0 and where cosine is equal to 0. Okay, so that's going to happen when theta is equal to 0 or pi. Cosine is equal to 0 at pi over 2. It's also equal to 0 at 3 pi over 2, but remember our interval, we're only going from 0 to pi. So these are my thetas. I need to now write them in the form of a point. So find where they are horizontal tangent. You're going to put them in the form of r comma theta. So my theta is 0. My theta is pi. My theta is pi over 2. I'm going to plug these into the original right up here and find out what the r coordinate is. Well, when I put 0 up here, sine of 0, 0. Sine of pi, 0. The sine of pi over 2 is 1. Okay, so these are the points where I have a horizontal tangent. Okay, now I have to find out where I have a vertical tangent. Let me see, I haven't used blue yet. So vertical tangent, that is where the denominator is equal to 0. So that's where cosine of theta equals positive and negative sine. Okay, well, cosine equals sine. They equal in the first quadrant and in the third quadrant, but I don't have to worry about the third quadrant because of my interval up here. So I'm only really worried about the first quadrant. I'm negative. They're opposites of each other in the second and the fourth, but once again, theta is in between 0 and pi. So this is going to happen at pi over 4 and 3 pi over 4. Once again, we're going to put them in the form of points, r theta. So 3 pi over 4 and pi over 4. So we're going to plug those values right in here for my theta. So sine of pi over 4 is square root of 2 over 2. Sine of 3 pi over 4 is still square root of 2 over 2. So these are the points where I have a vertical tangent. Okay? So tangents, you're talking about derivatives. All right, let's do another one. Woohoo! So now they're just coming right out and telling us no ifs, ands, or buts. They want you to find dy over dx. Okay, so on this last example, we found x, we found y, and then we did dx over d theta, dy over d theta. So now let's just use our other formula. So dy over dx is going to equal, remember, f of theta as is times the cosine, and then plus the derivative of f of theta times sine. We're going to divide the whole thing by the opposite of f of theta sine of theta plus the derivative of cosine. Okay, so remember r equals, that's the same thing as f of theta. So when I want to find f prime, well, the derivative of 3 is 0. The derivative of negative 3 sine is negative 3 cosine. Okay, so when I go to find it, everywhere I have my f of theta, I'm going to put 3 minus 3 sine times cosine plus the derivative, which is negative 3 cosine, times sine. over the opposite of 3 minus 3 sine of theta times sine plus the derivative times cosine. All right, so it looks like we've got it all in there. Now, all we have to do is put in 6 for all of the r's. Well, I don't have any r's in my equation here. And then put in 3 pi over 2 for all of my thetas. Okay, so all of my thetas, I'm going to put in 3 pi over 2. Okay, so when I look at that, that's going to make this really quite easy, because when I take the cosine of 3 pi over 2, I know that's going to be 0. So this term's going to be 0, and this term is going to be 0. Okay, this term is going to be 0. So I do have something on the bottom, but I have 0 on top. So 0 divided by any other number is still 0. Okay, so that makes that nice and easy. All right, so if they ask about the tangent line, they ask about increasing, decreasing, you know you're looking at that first derivative. Or if they come right out and just ask you to find dy over dx, same thing. All right, now we can find the area in polar coordinates. So if f is continuous and non-negative on the interval from alpha to beta, okay, and you're going in between 0 and 2 pi, then the area by the region bounded by the graph of r equals f of theta between the radial lines of theta equals alpha, theta equals beta is given by this handy, nice little equation. Okay, f of theta, remember, is the same thing as r. All right, so let's see what it looks like. Now, they talk about the area of one petal of the rose curve given by. All right, so you're going to want to change your calculator into polar. Okay, so just like we did our parametric, you're going to go to mode, and you're going to take it down to where you have function, parametric, polar. You're going to change it to polar. Now, when you hit the y equals, you've got r equals. When you hit the variable button, you get your theta. Now, when I'm looking at this, they just want the area of one petal. Now, for the most part, what you're going to want to do is you're going to want to find out where this equals 0. Because when you're making a petal, you're at 0, and then you're coming back to 0. Okay, so general rule, if you're having trouble figuring out where they are, just set it equal to 0 and see if that helps. If not, try some special angles and see if you can figure it out. If they let you use your calculator, you're not going to have any problems. But if we set this equal to 0, so we have 3 cosine of 3 theta equals 0, divide by 3, so we've got cosine of 3 theta equals 0. We need to find out where cosine equals 0. Well, cosine of pi over 2, cosine of 3 pi over 2 equals 0. So we're looking at where 3 times theta is equal to pi over 2, where 3 times theta is equal to 3 pi over 2. If I divide both sides by 3 or multiply by 1/3, I get pi over 6, and I get pi over 2. Okay? Now, we could do the same thing if we set 3 theta equal to negative pi over 2. We'd have negative pi over 6. So there's a lot of different ways we can take our area. If they, now this one's wide open, and it just said of one petal, so we could use any of those intervals that we wanted to. Normally, if they say in between 0 and pi, then we're sandwiched in between the interval we have. So when I go to find that area, I'm going to have 1/2 times my pi over 6 to pi over 2, and I'm going to take my r squared, so 3 cosine of 3 theta squared d theta. Okay, so that's going to get me the answer. But remember, I could take the area of another petal, so I could have done negative pi over 6 and positive pi over 6. Going to get me the same area, it's just a different petal. And I would find that the same way, setting that 3 theta equal to a pi over 2 multiple. Okay, so if you put those in your calculator, you're going to get your 3 pi over 4. Now, I throw down the challenge of you trying to find out what this is, integrating it without the use of a calculator. Just a hint, if you want to try this without the use of a calculator. 3 squared is 9, and then you have cosine squared 3 theta. Take that 9 out in front. And then you have cosine squared. Remember, if you just have a cosine squared or just a sine squared, you want to use that power reducing formula, that 1 plus cosine of, let me write the whole thing out for you. 2u over 2. So you can use this formula, substitute it in, and see if you can integrate this on your own without the use of a calculator and see if you get that 3 pi over 4. Give it a try. Okay, so now we can also do the same thing or use a formula to find arc length. So in our parametric, I believe we had a formula for arc length, but we didn't have one for area. But polar, just a little bit better, so to speak. Now on this one, same thing, you've got your derivative is continuous on the interval. Look at your little formula here. You've got the square root of r squared plus the derivative squared d theta. Okay, same thing here, just in function notation. Okay, so some of these examples are going to be very, very nice. For instance, this just goes out and tells you, find the arc length of the arc from 0 to 2 pi of this guy right here. So this becomes really kind of nice. Okay, so we've got the square root of, let's go ahead and find r prime here. Well, the derivative of negative 2 cosine of theta is 2 sine of theta. So we take r squared, I forgot my theta. They own it. Okay, squared. And then plus the derivative squared. Whoop. And don't forget your d theta. All right, so you put that in your handy dandy little calculator and it is going to give you a nice pretty answer of 16. Now, once again, we don't always get to use our calculator, so I throw down the challenge of see if you can figure out how you want to solve this without the use of a calculator. Hint, you are going to use your half angle identities. So give it a whirl, see what you come up with. If you have any questions,